Hello, everyone. Good afternoon, and welcome to this webinar organized by Dassault Systems Law Foundation for Seed the Future Entrepreneur Program. And I will quickly introduce myself. My name is Rahul Rai, and I am a certified SolidWorks mechanical design expert, and I create e-learning content. Recently, I have created courses for SolidWorks Desktop and XDesign web app. So, what is X design and what is 3D experience platform? Those things we have already covered in our previous webinars. And if you want to refresh your memory or you want to watch those, you can just go to the 3D swim community, and there you need to go to the uh, Seed the Future Entrepreneur season 2024-2025 community. There you need to go to the wiki, and there under this node you will find all the recordings of previous sessions, so you can watch these whenever you have free time or you want to refresh your memory and go back to what webinars have happened. So that was all for the quick recap, and so today's session will be focused on X design, and particularly about assembly modeling in X design. So let's get started. So there are actually two types of designing methods for assemblies. One is called bottom-up designing. So this is a conventional method. In this one, first you create parts and then you assemble all those parts to create the final product. So where do you use this? To create a bottom-up design, to use the bottom-up design approach, you need to know the exact dimensions of your individual parts, and then you assemble all those individual parts. Why do you need to know the exact dimensions? Because when you assemble all these parts, they need to fit perfectly to function together. So example of these things are that suppose you have to add some tires in one of your product. Suppose you are making a trolley. So for that you will buy some ready-made tires, you will buy some ready-made frames or handles. So those things are standard and you cannot modify them. So for those, you know the exact dimensions. You will just purchase those products from outside and you can assemble, add them to your product. So for those kinds of modeling, you use bottom-up design approach. And there is another design approach called top-down design approach. In this one, what you do, you start with an empty assembly, and then you create one part, and then create another part taking reference of the previous part, and this way you develop your product from scratch. So where do you use this? You use for these products in which you are creating parts which are specifically tailored for your product. So for those for that kind of product development, you use this approach. And see, none of these approaches, like when you are creating a product, you will not use either bottom up design or top down design. You will use a combination of both. Some products you are going to buy from the market for your final product. For that you will use bottom up design, and for some part of that you are going to create specifically, like brackets, and you will create fixtures, and so those things will be very specific to your product. For that you need to follow this top down design. So these two approaches are there to for assembly designing. Okay. So yeah, so today what we will see that so first quickly I will show you what can you do in X design, and then I will show you how you can do that. So quickly what I will do, I will open this assembly design so that I can show you what are the possibilities in X design with respect to creating an assembly or seeing its motion. So this is an example of a cylindrical robot configuration. Okay, so here you can see that this is there are five parts. First part is fixed. This is more like a ground related to which all the parts will move. And then there is this first part which moves, which help the robot arm move in a, which help robot arm to rotate around its axis. Then there is the second part which helps this arm to move up and down. And then there is this third part which let it move to and fro. And then there is the gripper. So this can be a gripper, this can be if you are going to, so in industrial use it can be a welding gun, it can be a riveting gun. So it is mainly called an end effector. So to control like where this can go, you can create an assembly in X design, and you can have different parts. So what I will do, I will share all these five parts with you guys. And if you want to follow what I'm going to do, you can just download these and use that in XDesign. So I will quickly add all those files in the chat. So give me a minute. So now there is a zip file in the chat. You can download that and extract that zip on your desktop. I will give you 2 minutes to do that, and after that I will show you how you can upload those content on the 3D Experience platform, and then you can use that in the XDesign to create an assembly. So you guys can quickly download those parts from the chat and extract that on your PC. Meanwhile, I will play with this robot. So, and this all is based on cloud. There is no installation. I have just logged into my browser and opened it, and it was there. I will show you one more cool thing that, see, this is creating from assembly modeling. You guys can understand that, yeah, I'm going to assemble some few parts. So that is, evident from assembly modeling. But what more you can do in X design is that you can create mechanisms out of these assemblies. So what is the benefit of creating a mechanism? When you create a mechanism, you can control the motion or control all the degrees of freedom, all the motions which are happening in this model, you can also control. So I will show you how you can do that also. So I will quickly show you that. So there are, I told you like there are three motions. One is rotation, rotation about the base. One is vertical motion, and one is horizontal motion. So I can control these three motions, and I can also record these motions. So I have already recorded one motion. So if I play this, you can see first it go up, then it rotate, and then it go horizontally. So these three motions are there. So you can record these motions. So this will help you understand the relative motion between your product, and also it will help you to show somebody else that what your product can do. So it is a very, good thing to have in your presentation, not just a static image, but a video which will show that how your product is going to move. And all of this is based on a web app. There is no installation. So I hope everybody have downloaded the parts and extracted them. So now to use that in XDesign, first thing that you need to do, that you need to create a collaborative space. So I know that most of you have a collaborative space created for your school, but I would suggest you to create a new one for this test, or you can use that one also if you find comfortable. So now if you have a collaborative space, then what you need to do, you need to open the 3D drive. So you can quickly access this from this content icon. When you click on this, this 3D drive will be open, and there what you need to do. So I will just quickly delete this, and I will show you how you can upload your content on the cloud. So wherever you have downloaded that content, there must be this folder. In the folder, you have all the parts. So just drag this folder in the 3D drive, And now all of your parts are on cloud. So when you open this, you can see all of your parts. So one, two, three, four, five. Now I will quickly close this one. Okay, so now, so we are going to use that. We are going to use the first approach, bottom up design. In the bottom up design, creating the parts, that first step we have already done. Now we just need to assemble those parts. So what we will do, we will create a new component. Let's name it test, and then we will put it into the collaborative space, either your school's collaborative space, or you can create a new one to use that. So I have given a name, I have selected a location, and then okay. So now I have a new component. So in X design, one of the benefit is that the part design and assembly design both are done in a same environment. So right now, either I can use it to create just a part, or I can use it to create assemblies also. So I have created a new component, and all of my component are on 3D drive. So I will import the first part, which is the base. So I just need to click it, drag it, drop it, and then I need to select it that yes, it will be in this collaborative space, and it will be insert into the current component to create the assembly. And how many of these I want to add? Suppose if somebody is creating a robot, it will have two arm, two legs, or two eyes. So instead of one, I will choose two. But right now there is just one base, so I have selected one, and I will now click on import. So now my part is added into this test assembly. And the first part that I have added, now I will fix this. So to fix this, just click on your part. You can expand this menu, and there is this option to fix component, because this base part will be attached to earth, or whatever, like if you want, this is the part relative to which all other parts will move. So I have fixed this one. So always make sure whenever you insert your first component, it is the part which you are going to fix, so that you can assemble other parts accordingly. So we have uh, inserted our base in this. Now we will insert the second part. So we just need to click, drag and drop, and collaborative space is okay, and it will be insert into current component, and instances will be one, and I will import that. So right now this one, placed at origin, but suppose if it is placed somewhere else, so how easily you can move the components? Just click on them and drag them. So if you click and drag, you can move your component in the 3D space very easily. And if you want precise movements, you can select a part, this robot will appear, and then you can click on any axis, and then you can enter numbers also. Like suppose I want to move it by 20 mm, so now it is moved by 20 mm. So these things are possible. And yeah, but now when I am in the when I showed you the full assembly, you saw that it was just moving, revolving around this base, but right now it is freely moving everywhere. So what should we do? Like if it was a physical part, what would you have done? uh, Basic thing is that we will add, some kind of you can say a nail or something to make it connected with this part. And if it is at the center, then it might rotate. So in this one also, like to create revolutionary joint, a prismatic joint, there are combination of mates that you need to do. So first thing that we will do, we will align this cylindrical surface and this cylindrical surface. And so in X design, whenever you select two different parts, it will automatically show you which kind of mates you can add. So concentric, perpendicular, parallel, tangent. So all of these mates we can add. So right now we will just focus on concentric mate. So from its symbol also you can understand that it will just make axis of these two cylinders coincident. So when I select that, you can see that now these two cylinders, their axes are coincident. So what this mate did, that now if I try to move this part, it will move in just one linear direction. And if it is also rotating about this axis. So now I need to make it move, its I need to stop its vertical movement. So what I can do, I can just select this face and this face, and then there are more options. So there again there is this option coincident. Right now this symbol is different. This symbol says that these two plane will be, in a collinear manner, so they will be aligned to each other. So if I select that, you can see that these two faces are kind of glued together, but not actually glued because there is still a rotation motion available. So I added concentric, I added coincident, that made a revolute joint. From its symbol, you can understand that this means that there are two cylindrical faces which can revolve around each other. So our our base part and our first part are attached. So this is how you are going to join multiple parts in an assembly, and the kind of relative motion you want, accordingly you need to add different kind of mates. So for this revolute joint you need one concentric and one coincident mate. Now we will add the second part. So I will just repeat the same step. I will click and drag, and then I will insert it in the current component only one instance, and I will import that part also. So right now even that part is at origin. So but it is not fixed, so I can just go there, click and drag it, and I can move it anywhere in the assembly. So from the shortcut menu, if suppose your parts are too zoomed out or too zoomed in, from the shortcut menu you can select this trimetric view and then reframe, and then it will look, it will fit your component on your work area. So now we need to constrain this part about this second part about this first part. So we will select this plane and this face, and then we can make them coincident. So now, so always make sure whenever you add a mate, you check like how it is going to affect your assembly. So yeah, this is the motion that I wanted. You can see like this plane is always coincident with the second plane. From top view, it will be much clear. Yeah. So now, yeah, we will add another constant. So this was one of the way that you select two planes and accordingly you get these mates. The other way is that in the bottom taskbar, action bar, you can see this assembly tab. In the assembly tab, there is this option called mate. So when you click on this, it will ask you to select two geometries. So I will select this face. So whenever you select face of a part, it becomes translucent, so that you can select another face of another part very easily. So I will select this one. So when I select these two faces, these options are available. And now I will again select this coincident mate, and I will click OK. So that was the another way to add mates in an assembly. And now since I have this face, these two faces constrained its movement in x and y axes. Now it can just move up and down. Okay, so now we have got two motions, like we can rotate and we can move up and down. Now we need to find a way to move our gripper in horizontal direction. So for that we have the third part. I will just click, drag, release, and then I will insert into current component and click import. So if so this right now, all of these parts, since I have shared all of these parts with you, so they are already constructed, and you just need to import them in the X design. So I will quickly add another coincident mate and this mate. So now you can see that this part is interfering with the other part. So when you select a mate from this design tree, so in the design tree, like these are all our parts, and in the parts we have all the features. And after all the parts, when you assemble these, there are a list of mates. So when you click on any mate, you will see like which faces are actually mated. So if you go to that Revolut mate, there we have this concentric mates, and concentric mate, this cylindrical surface and this cylindrical surfaces are mated. And in the for coincident one, it was the top and bottom phases of the cylinders. So but now this part is interfering, so we will see like which mate we can change to get what we want. Okay. So this mate, when you select a mate, you get an option to either reverse it or edit it. So I think by reversing this mate, we will fix it. Yes. So whenever you find a problem in your assembly design when you are meeting, you need to fix that as soon as possible, because uh, if you delay it and assemble other parts, then rotating, fixing that will cause you a lot of harm, because you need to fix a lot of mates. So what we will do, I will just quickly show you an example. So I have pressed Control plus Z and I have reversed this change that we did, and I will quickly add the gripper. So, and remember that we have not corrected this part yet. So we need to, flip this mate. But I have not did that. I am thinking that first I will assemble that gripper and then I will do that. So what kind of problem I will face is, so first let me add mates between this part 3 and the gripper. So in this one, yeah, so now I need to add another mate. So I think this, if I make this face and this face coincident, yeah. So now it is fixed. So you can see like as I am adding mates, things like these mates, their parent mates will also change. So I will show you that. So right now, the gripper is free. When I select it, none of these mates are associated with it. And now if I select this face and this face and make them coincident, you see now there is a mate there. Now it says that it is a planar mechanical connection, that it will move in x and y direction. Now if I add another mate, now it become a prismatic mate, that now it can move in only one direction with respect to this object. Now if I add another coincident mate, so I have restrained all of x, y and z axes, so that's why now it has become a rigid mate, that this part will move rigidly relative to this part. Okay. So now if I try to correct this part, and I just need to flip this one, you see the effector move from right side to the left side. Now if right now this is a symmetric part, so it will not make more sense to like fix this gripper to again this side. But if it is a asymmetrical part, then you need to like again delete all the mates and then add this part here. So always try to fix any error in your mates as soon you catch them. So we have created this assembly now, and so if I select just this gripper, I can move it anywhere, and accordingly I can see like what kind of motion will be there. Now let record some of this motion so that we can create a video to show how this part will work. So I will just adjust it to some initial position. So let's say it is grounded and it is like something like this. Okay. So in assembly, yeah, I will just close this content dialog box. Now in the assembly, there is an option called mechanism. So when you click on that, so just use this option, all products and mates. Other options are a little bit advanced. So just use just this one, all products and mates, and click on OK. So it will create a mechanism for you. Now to control your mechanism, you need to select this kinematic player. All of these are in this assembly tab. So in the kinematic player, when you click on this first option, manage control degree of freedoms. So which of these motions we want to control. So right for now, let's select all of these. And if I go back, now all of these are here available and I can use this slider to control any of these. So for Revolute one, we can rotate the part one, and with this prismatic we can control the horizontal motion, this which is the part 2, and we can control part 3 with this prismatic motion. Now to record, what we need to do, first we will start with some initial conditions. So suppose let's this one is 0, this is 10, and let's put it 0 also. So this is our initial condition. So and then we press on this button, this record animation. So when you click on record animation, you will get another dialog box. And now what you need to do, you just need to make some movements, like suppose we want to move, rotate our robot arm with 45-degree, and then we will add this position in our recording. And then in the next step, maybe it will move 40 mm upward, and then we will add that. Now it will move 40 mm upward. And then yeah, so for horizontal movement, suppose it will move 30 mm, and then we will add that movement also. So now all of these three movements are recorded. So if I click on this play button, it will play each movement one by one. So this is how you can control your motions and also record them. And if and when I click OK, this motion will always be recorded in this kinematic player option. So if you want to replay that, just click on this and this record animation player, and then just click on play, and your recorded animation will play. And you can capture the screen and use that in your product demonstrations. So that was how you can create an assembly. So this was the first approach, bottom up design, where I have already provided you some parts and then you use those parts to create assemblies. Now the second approach is top down design. So why you will use that approach? So suppose right now you have this assembly, okay, which any of your teammate created, but then you thought that so I will just quickly show you one tool. So in this tools tab, you will have this measure tool. So this measure tool, it helps in you measure everything. So if I select any component, it will give me like what is this parameter, what is its area. So it is more like a measuring tape. So in an assembly, like it will help you to measure the parts and see what are its dimensions. So if I click on this vertical bar, instead of this bar, I will click on just one side. So its length is 90 mm. So that means it can go up to 90 mm only. But I want it to go, suppose 150 mm. So right now I will not, one way is that I can open this part, edit this part, and then go back to assembly to see how it looks. Or what you can do, you can just select this part either from work area or from the design tree, and there is an option, uh, edit it. So now what you can do, since it is created in Xdesign, we have all the features and we can control them. So this feature, extrude to, it controls its height. So now I can just move it to 150, and now I will go back to my assembly. I will just refresh the assembly, and now you can see that it can go up to like 150 mm, 130 mm. So this is the power of uh, top down design, that you change things with respect to the assembly. And also like so in this way, suppose you want to change this gripper with something else, so you can just edit this one, or if you buy some another gripper, you can just use that 3D, insert that 3D model in this assembly, and you can create a new assembly altogether. So this was a quick overview how you can create assemblies in Xdesign. Now I will share some best practices for creating mates. So as I mentioned that you first insert the base part and you try to create all the mates with respect to them. If there are like multiple parts, you use that, and you should avoid like referencing one part then another part and creating loops. So that you should avoid. And so uh, so yeah, so what that means that right now this part is mated with this part and then this part. So to you know resolve that, what we will do, we will try to have a connection between this part and this part. So for that, what we can do is we can either modify this part. So since it is created in Xdesign, we will use this top-down approach, and we can add a prismatic section on this. So we will quickly go to sketch. We will create a center rectangle, something like this, and I can quickly extrude that. So let me change its dimension a little bit. So you can select any part and dimension it in the assembly altogether. So now we have this, and then you can hide the first part, and then you can directly add it. So now we will just remove the mates. Yeah, I will just expand this window, and it was, I think, these two one, right? So I can just disable those. And now, yeah, so dimension of, so the benefit of modeling in the assembly is that you can quickly take measures. So this is 20 and this one is also 20, I think, because it is a square. So I will quickly take the measure. Yeah. So now accordingly, I can edit this part. So I need to just edit the sketch. This one is 20, and this side I will make that side also 20. Maybe I need to redo this feature. And now I can add mates. So now we have removed that rotation motion and we have directly assembled this part on this base part. So now we have just horizontal vertical motion. So accordingly, if you want to like remove any more motions and if you want to add any motions, you can directly edit things in the assembly to create new assemblies. So yeah, and so that was the two approaches that you can use, bottom up design and top down design. And now, if you have any questions, I open the floor for Q&A. You can ask your questions in the Q&A section of the webinar. Yeah, so in this session, for those who have joined late, a recording of this session will also be shared. So don't worry. So what I did in this webinar, that I started with what is bottom-up design and what is a top-down design, and where you should use this. And then I demonstrated how you can import some parts in XDesign and create an assembly and then record the motion. So that I after and what are the mainly best practices that you add mates with reference to fixed component, and you should always avoid looping of mates. Never make a circular connection. Always make sure that there is a linear chain or there is a branch chain of mates, not a loop. So and so almost like covered only these things, that what are the assembly design for 3D part. Yeah, so I also covered that all the recording of the previous sessions are also available on the community. So you can watch this session and also the previous sessions from the community wiki. Any more questions? So how to save the model? Okay, so I will quickly again demonstrate you. So first you need to download it on your computer and extract the zip. So in that zip, you will find this folder assembly webinar, and there you will have all these parts. So once you have all this 3D XML, so if you are if the format is different, like if there are SolidWorks parts, the process will be same. First, you need all those parts on your computer, and then here on the 3D Experience platform, there is an option for content which will open the 3D drive. Either you can access it from here, or you can open the 3D drive app also. Yeah, from here. So this option is very handy. So I always use this option. So now what you need to do, you need to open the 3D drive, go to, and then, so I will just delete this folder. So all the parts that you want to upload on the cloud or save on the cloud, just put them in a folder. Okay. And then in the 3D drive, you can upload them. So there is an option to upload folder or a file. And the quickest way is that you just drag and drop the folder on the 3D drive, and it will save all of your content on the 3D drive. So right now they are on 3D drive, but to use in XDesign, you need to import them in a collaborative space. So what you need to do, you need to, yeah, so once they are on the 3D drive, select any of the component and just drag and drop them on the XDesign web app. And then you will have an option to choose in which collaborative space you want to save it, and then just import it, and then you can use it in XDesign. So right now I imported just one part, and similarly you can import all of these parts and you can use them in an assembly. So yeah, I will just quickly show you that if you have already imported everything in your collaborative space, then in the assembly tab there is an option to import either new component or insert new component, or you can insert an existing component. So when you click on an insert existing component, you can select a collaborative space, so where you have imported all of your content, and then you can use the start search option. So right now this one is empty, but I will quickly show you. So all your recent parts will already present in the this dialog box. So from there you can select any of those. So all of my previous parts are there, so I can select this one and it will be imported. So yeah, so the first one is, so I have imported this component in the gripper. So that's why I cannot move the gripper because it is a design feature. So what I can do, I can just create another component out of this. So these things are a little bit advanced. If you want to understand these things, like it is available on the edu space. There is a course called XDesign, SolidWorks XDesign for Education. You can go through that course, or there are other resources on the wiki to understand. So just like the recordings from the previous session, there is also XDesign training material available, and it will help you to move from XDesign to 3D printing. There is a step-by-step guide for part modeling and also a step-by-step guide for assembly design. So if you have missed this session, don't worry. You can go through the recordings, or you can use this, self-paced XDesign material which is available on the wiki. Yeah. So to access the recordings, go to the community. So which community you need to go? You need to go to Made in 3D Seed the Future Entrepreneur Season 2024-2025. So this is the name of the community, and from there you need to go to wiki. So if wiki is not visible, there is the section called more. From there you can see. So it depends on like if this option is this left panel is on or off. So you need to go to the wiki, and there in this node you will find the recordings. So soon we will add this webinar's recording and also part modeling in XDesign. So both of the webinar which were focused on XDesign, their recording will also be available soon. So we have till 3D Experience Platform Essential, and the other two will be added soon. And for the XDesign training material, you can access this node. Any other question? Uh, any other way to save? So uh, this one is the one of the quick way to save your parts on the. Yeah. So if you want to, so you want to save your part on your desktop. So for that, what you need to do, there is this option. Instead of save, you can select this export option. So what the export option will do, export option will save your 3D XML on your desktop. Okay. So if you select the export option, yeah, first it will ask me to save it on the cloud. So once I save it on the cloud, then it will give me an option to export it. Yeah, so now I can export it on the disk. File on the disk means that it will save on the desktop, and 3D drive means it will go to this content dialog box. So in 3D drive. So to save it on your desktop, you need to select file on the disk. You need to give it a name, and then you can select a file format. So 3D XML is the file format for XDesign, And if you want to 3D print, you can select whichever file format is appropriate for your use, and then you can just click export, and then this exported model will be available in your desktop, wherever is your download folder, you can find it there. So just look for the file name gripper and you will find that. So if so whenever you create yeah, so now it is asking me where I want to put it. So you can put it in your folder and make sure that you remember that address and just click save. So it will be downloaded. So when you export it, it will go to your desktop. And if you are saving it in cloud, after creating, if you create anything in XDesign, it will be saved on 3D space. So you just need to go to the compass, go to the compass, search for 3D space, and you can launch this app. And so right now I have access to a lot of collaborative space. You need to find your one. For you, it might be one or two, and then you just need to open that collaborative space. And I will just quickly show you where all of my created parts are. So this was my collaborative space, and there you can see all of my parts are available here. So just make sure that you remember in which collaborative space you are saving which part. Since to show you guys, I have saved my part twice, so you can see like my part name are there. Yeah, to share any file with another user. So suppose I want to share this.
Hello. Yes, I would like to take this question. So, if you are trying to share these files with your team members, then if you are using the collaborative space which is already created for your school, which is by the name of your school, so whenever you save the part in that particular collaborative space, it will automatically get shared with your team members, whoever team members you have. So it will be like your six team members, then your teacher. That file will be directly shared to them. So there would not be any issue, and you won't need to actually share that particular part with each of them, and it will be directly be visible for them, and they will be able to work on that particular part.
Thank you, Kundlik, for explaining that. So what you need to do, suppose your teammate want to see what you have created. So just ask them to log into their 3D Experience platform and go to that 3D Space app and look in the collaborative space. So it is a common repository for your school, and whoever create one part, it will be visible to everyone. So how many of you have started with designing your part? Can you give a yes, or you can raise your hands to show?
So, yes, we have the question, is the collaborative space only visible to us, or the I think it is evaluator can also see it. For now, the collaborative space is only shared with you all, with the team members, and it will be visible to the organizing team only. So whoever administrating the platform, only they can see that particular collaborative space. But if you want to create something for your training or personal projects, then you can create a new collaborative space also. And, like how Rahul have showed us in start of this session. So that could also be done. But if it is about the school's collaborative space, then it will be only available to you, your team members, and only the platform administrators, not other members will be able to see that.
So if you guys face any problem like while creating an assembly, just share your questions on the community, and we will make sure that somebody address your queries there. If right now you are you like you have just started with 3D design and you have to yet move to assembly design, and if you face any problem, feel free to share your queries. We will wait for a few more minutes to address questions. If there are no more questions in 5 to 10 minutes, I think we can close this webinar and we can address your queries on the community. So if you have any questions, please ask. So thank you everyone for attending this webinar. I hope this was all informative and it will help you in your journey of Seed the Future Entrepreneurs. And I'm okay, so we have some questions. So, sir, can we create robot? So yes, you can create robot, and as I have shown you that this is a kind of a robot in which the space which it can access is cylindrical. So see, you need not to create each and every detail of something like the circuit board, the capacitor, the wires. So in X design, you need to focus only on the what are the motions that the robot will perform. So similarly, to create this robot in a real world, I need to add motors, I need to add wires, I need to control it using a microcontroller. So I have avoided all these things and I have just created what will be the mechanical parts which will be necessary, like this arm, this up and down motion, this rotation motion. So you need to simplify your robot and find out that to attain the specific function, like suppose it need to lift something or it need to pick and place somewhere, so for that what exact motions it need, and accordingly what are the mechanical components that you need to create. So from this you get the dimensions and you can share these dimensions with the fabricator, or you can 3D print these parts on a 3D printer, and then you can add motors and other things. So yes, you can create a motor, but it will be, you need to find out how you can uh, achieve that motion, and for that you need to model it in X design. So is the collaborative space available for teachers? Kunlik, I think you can answer that.
Yes, the collaborative space is also available to the teachers. Actually, it will be available to each team member or enrolled person for that particular school. So yes.
So I will again share the parts and also the complete assembly so that you can open that in X design and explore it. So I will quickly share that. So the zip file that I have shared, it have all the parts, and the 3D XML file, and its name is cylindrical configuration. So that 3D XML file contains the total assembly. Yeah, so how to restore our work if it is interrupted by some network issue and the restore option is not available. So, see, this X design it needs a stable internet connection. So if your internet connection is not that stable, like suppose it is fluctuating, so one of the thing is that you will get to know that your internet connection is not so from the system status, it will show you if the everything is good or not. So if any one of the resources are like not functioning properly, make sure that all the internet connection and all those things are okay. And even if like suddenly if the power goes off and you do not have internet connection, right now it that option will not, you will not be able to see that, but there will be one other option called restore files. So in most of the cases there will be an option to restore your lost work. And if it is not there, so one thing that good practice which I follow, that after every 5 minutes, 10 minutes or any major change, I make sure that I click on this save button. So that is the only foolproof way to make sure that you never lose your work. And if somehow it happens, there is a very good chance that it was saved by X design and there will be an option to restore component here. And I will encourage all of you to use these resources also, these user assistance option. So here it is more like a self-help, documentation. Here you can explore like other things. Suppose you want to learn about a particular mate in assembly design. So in assembly section, there are this mates option. There are these types of mates. So angle mate, coincident, concentric. So all of those mates are available. And then when you combine those mates, then what kind of functional joints will be there? Cylindrical, rigid, revolute. So you can explore these things from here. So I will encourage you to go through that. And also you can go through this course. I hope you all have gone through explore the 3D creator role. This will also help you, hone your skills in X design. So what I have shown you is just a small, quick way to introduce you through assembly modeling in X design, but this will help you go dig deep in the X design functionalities and how you can master it. So I will highly recommend to go through these things. Sir, can we do in Tinkercad? It is very easy, user friendly in X design. If See, the problem is if you use multiple software to do multiple things, it is very easy to lose data and you will not be able to complete your project easily. It will be much easier to do everything in X design rather using other softwares. I would recommend you stick to only one software, one ecosystem when you are creating a product. So, thank you everyone for attending this webinar. I hope I was able to answer your questions. And if you have any questions, feel free to post your question on the community. You can ask on the WhatsApp group also, and we will try to answer all your queries as soon as possible. So, thank you everyone. Have a nice day. Bye bye.